Alright, today we are doing the binomial theorem, which is an extension of certain algebraic patterns you've seen before. So you've all seen this, I'm sure, that when you square this bracketed term, you get a squared, 2ab, b squared, and there's a version for cubes as well, which you may or may not have seen. But once you go higher power, it gets a little bit annoying to manually expand everything, and we'd like a way to be able to do this quickly and in one go if possible. Okay, but before we get there, we're going to do something a bit different. We're going to be assigning meanings to A and B, and by meaning, I don't mean numbers. I don't mean that A and B stand for numbers. I mean that they're actually going to have like meanings in a story. Okay, so let me just pause there for a sec and get you to imagine that you're at an ice cream store where there's vanilla, there's chocolate, there's strawberry, and there's banana. Okay, there's those four flavors. And at this store, you're not allowed to get two of the same scoop. So you get an ice cream cone, and it's like you go across each of these flavors, and you can choose to either take it or to not take it as you go across each of these four. All right. So for example, you might want a vanilla, you might want a chocolate, you might skip the strawberry, and you might take the banana, and so you have a 3-scoop ice cream, right? But you can't repeat the flavors. You can choose to take it or to leave it, okay? So put this cone aside for now. What we're going to do now is actually use this to try to figure out what's going on when we're expanding brackets. And the way we're going to do this is we're going to make each bracket be in charge of a particular flavor of ice cream. It might seem weird at first, but I hope it's going to make sense. So as we go across each of these brackets, it's like we have a choice to either take the A or take the B, and what we're going to say is A means we take the flavor, and B means we leave the flavor. So if I expand this bracket, maybe the first thing I do is I go across and I expand out all those ones, and if I do that, I want you to think of the meaning of this as that vanilla's got A, chocolate's got A, strawberry's got A, banana's got A. They're all using A, and so we're taking all four ice cream flavors. Okay, now of course expanding out, multiplying these things out, you're just going to get A to the power of 4, right? And we want to interpret that as just the selection of taking all four flavors of ice cream. Okay? Might be weird at first, but let's see another one, and it might make a bit more sense. Let's say we're expanding, and we choose to multiply that by that and go all the way there this time. Okay, so that's going to be the term a cubed b. So we've got b, that's a cubed b. All right, and again, we interpret this to mean that now vanilla's got an A, so we take it. Chocolate's got an A, so we take it. Strawberry's got an A, so we take it. But banana's got a B, so we drop the banana. We just have these three. Okay? Now, that's one selection of 3 scoops, but we could have done another one, couldn't we? We could have gone, say, there, where we take vanilla, we skip the chocolate, it's got the B, we take strawberry, it's got A, and we take banana, it's got A as well. Right. And so the question really becomes, how many of these 3-scoop selections will we have? Because each 3-scoop selection corresponds to another copy of A cubed B. Right. So how many of these 3-scoop selections will there be? Well, we're just choosing 3 of the 4 flavors. And we just learned how to do that. That's 4 choose 3. That equals 4. And so in the final expansion, we can go straight to the end and say because there are 4 selections of 3-scoop ice creams, that must be 4 a cubed b's then, because each a cubed b is just a 3-scoop ice cream. Okay? And so let's look at the next one. What if we do this? A to B to B. So in this one, the algebraic term is an a square b square, right? But what's happening with the ice cream? Vanilla's got an A, chocolate's got an A, so we're taking those 2. But strawberry and banana have B's, so we're leaving those 2. So we only have those 2 scoops, right? And just like before, every a square b square possible comes from taking a particular 2-scoop ice cream. all right, because that's where the 2 copies of A would come from, taking 2 scoops, and 2 copies of B means you're leaving 2 scoops out. Okay, so how many 2 scoop selections of ice cream are there? Well, we choose 2 of the 4 flavors, and that's 4 choose 2, so we get 6. And likewise for the next term, I think you can see where this is going. If I go A to B to B to B, that means I have AB cubed as my algebraic term, but the meaning of this in our story is we only take the vanilla one. We only take 1 flavor. And that's kind of obvious then. There are 4 selections of 1 scoop ice creams. Okay, and so that gives me 4 AB cubed, because each AB cubed means I'm taking only 1 flavor and leaving the other 3. Okay, and the last one is where we go B, 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 which means that I'm some psychopath that walks into the ice cream shop with an empty cone and says, I don't want any ice cream, just give me the cone. Right, and so that's the 1 selection, B to the 4, the empty cone. Okay. Now the pattern, there's a very predictable pattern to this, and I hope you can see it just from what we did there. But I hope you understand why it appears as well. So the pattern is really this, where you can see the powers of A go from 4 to 3 to 2 to 1 to no power of A. That was taking the 4 scoops, then 3 scoops, then 2 scoops, then 1, then nothing. Right. And the powers of B sort of follow suit. They go from nothing to 1 to 2 to 3 to 4. Okay, and so that was the ice cream scoops we were leaving out, I guess. And then to count those selections of ice cream, we have 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4. And so that's the pattern of expanding these brackets. And so if you calculate those coefficients, you get this. The A4, 4a cubed b, 6a squared b squared, 4ab cubed, and b4. Okay, and so this pattern works no matter how high the power is. And so if I say go to a plus b to the 5, well, all that does is it makes all the coefficients go to 5 choose 0, 5 choose 1, 5 choose 2, and so on. And it also makes the powers go from A5 to A4 to A3, A2, A1, no A, and likewise for B. It goes from nothing to B1, B2, B3, B4, B5. Okay, and I hope you can see that pattern, but I hope you can also see why it happens that way. Okay, I mean, you might have to rewatch some of that if it's not clear. I know it's weird to think about algebra in this way if it's the first time you're seeing this. Okay. But it gives us a nice way to expand it quickly without really expanding anything. We just calculate those combinations, and you can get those coefficients immediately without expanding a single bracket. So that's really nice. Okay. Now your text is asking questions of this form, so I think I'll do one with you. So evaluate a plus b if root 2 plus 3 all cubed is a plus b root 2. Okay, so we use our expansion pattern, which looks like this. Okay, I'm going to pause here for a bit, make sure you understand every piece of the right-hand side, right? You've got the combinations, the 3 choose 0, 3 choose 1, 3 choose 2, 3 choose 3. You've got the powers of root 2 going from 3 to 2 to 1 to nothing. And you have the powers of 3 going from nothing to 1 to 2 to 3. Okay, so that's the recipe we had from the previous slides. Okay. Now the easiest way to go about this, I think, is you work out those combinations first. So 3 choose 0 is just 1. 3 choose 1 is just 3. 3 choose 2 is just 3. And 3 choose 3 is just 1. Okay, for higher powers, you might need to put it in your calculator. This one's kind of easy, but you might need to use a calculator for that. Okay. So this then simplifies to this. That's just replacing all those combinations with what the numbers actually are. Here I might take the first term, the root 2 cubed, and I might pull that apart. That might be root 2 squared and root 2. Of course, root 2 square is just 2. So we get 2 root 2. Okay, so keep in mind that first term is 2 root 2. That means that this simplifies to that. I've also done a few of the multiplications there. And then we collect the root 2's. So I've got 2 of them, 27 of them. That gives me 29. And then I add the regular numbers as well. So we get 45 plus 29 root 2. Okay. We were after a and b. Well, just compare it. We get a is 45, b is 29. Okay, and so that's how we can expand those brackets. That's the main point of this this section, and you'll be using that in a few other places later, in probability and in well, mainly probability. So you'll see that later. Okay, there's a few other things you can do with it as well. But thanks for watching. See you next time.